Hello and welcome back to part 7 of the Delaware Tech Physics 111 Exam 1 Preparation and Practice Exam covering motion, also known as kinematics. In this section, we're going to talk about actual kinematics equations and how to use them. So, shown here, you see this big table of formulas, but before we get to this big table of formulas, I want you to note the very first sentence here. Only use these equations when acceleration is constant, meaning constantly zero, constantly a positive number, or constantly negative number. Now, if the acceleration is constantly zero, you can use these equations, but please don't. Use instead the simplified version of the equation, and that simplified version can be written in a couple different ways. This is the same equation, and if it looks familiar, this is the same equation as the speed equation. We use v to represent both speed and velocity. In this case, it's velocity. In what I'm about to write, it's speed. So it's distance over time instead of displacement over change in time. And I can rearrange this equation just like I did the one below to be distance equals speed times time. And you can do it either way. For most of these problems, it's not going to matter whether you think of it as distance or displacement, or whether you think of it as velocity or speed, because in most of these problems we're going to give you the direction is the same all the time. So you're always going to the right or to the left, or so it doesn't really matter which formula version you use. They work the same way. So use these if the acceleration is zero. How do you know the acceleration is zero? Because you'll be told that the velocity is constant, or you'll be told that the rate is constant, or you'll be told the speed is constant, and you can imply that the direction is constant. So if the speed is constant, the velocity is constant, it's not changing. By definition, acceleration, which is the change in velocity with time, if there's no change in velocity, acceleration is zero. And in that case, just use these simplified versions of the formulas. Now, if you have reason to believe that the acceleration is some other value, some positive value or some negative value, that is constant, you can use the 5 kinematic equations in the table. Now, you can't use these equations if you have reason to believe the acceleration is changing. Now, all the problems we're going to give you in this unit, the acceleration will be constant. Constantly zero, constantly a positive number, constantly a negative number, at least the problems in calculations. In the plots, in the graphing, that's different. If you have an acceleration that's not zero and it's constant, use these 5 equations. How do you know which equations to use? Well, you'll notice these equations have 5 different variables. Delta x, which is the change in position, we call that displacement. V sub I, which is the initial velocity. V sub f is the final velocity. A for acceleration, and delta t, which is the change in time, or you can just think of it as how much time it takes. Okay, and you'll notice each one of these 5 equations uses 4 of these 5 variables. One of those variables is not in the equation. And you'll see on the right side of this table, I put check marks if the variable does appear in the equation, but more importantly, the word missing if the variable is not in the equation. And when you're doing classic kinematic problems and you know there's a real acceleration that's not zero, you want to use one of these 5 equations. The way you select the equation you use is you ask yourself, what are the givens in this problem? What values, which of these 5 values do you know from the problem? They might be stated outright with actual numbers, or they might be in some wording that allows you to figure out the value of them. But once you know 3 of these and you're asked for a 4th value, you look for the equation that includes those 4 things. And that's kind of a pain to do, go through each equation. Does it have this, 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 and this? Instead, just ask yourself, what's the one thing I don't care about right now? and then look for the equation where it says missing, and then you know which of the 5 equations to use. Now, this set of equations is for horizontal motion. How do you know that? Because we use delta x for displacement, and delta x is change in position. Technically, it's change in horizontal position. So you use these formulas if you're moving horizontally, to the left, to the right. And a could be any value in the problem. But if you're dealing with a vertical kinematics problem and you know that the acceleration is constant, there's only one acceleration you're going to be using. And I'm going to scroll down and you'll see what formulas they are. These are the vertical kinematic equations. They're exactly the same equations, except instead of delta x for horizontal displacement, we use delta y for vertical displacement. No different. It's the same equations. And since the acceleration in vertical problems, if it's constant, it's always the same constant. It is g, which is minus 9.8 meters per second squared. And you're going to find that in your formula sheet if you don't remember it, minus 9.8 meters per second squared. And in kinematics problems, it's very important to remember vertical problems, we assume that the up direction is positive, the down direction is negative, and gravity points down. So gravity is a negative acceleration. Now, if we look at the next page here, the next page are basically strategies for how to use these equations to solve kinematic problems. And the assumption here is we're not talking about the simplified speed equals distance over time problems when the acceleration is 0. I'm talking about standard kinematic problems where you know there is an acceleration that's some positive value or some negative value. So you're going to read the problem carefully, and that's true for any problem. You're going to write down the parameters you know, and that will be true for even the simplified kinematic problems that I just mentioned. And you can make a table. If you're making a table for the simplified kinematic problems where acceleration is 0, well, then there's only one velocity. So it's one velocity, one distance or displacement, and one time or change in time. And those are the 3, and you need 2 of them to calculate the third. But in standard kinematic problems, we have 5 variables we might be interested in. So it's important that you look at the equation carefully and ask yourself, what are the givens? What are the values you are given in the problem? And they're either explicitly stated, they'll say, oh, the acceleration is minus 4 meters per second squared, or the initial velocity is 20 meters per, positive 20 meters per second, or it's 20 meters per second and you know it's going to the right, and therefore it's positive 20 meters per second. That's where it's explicitly stated, but it might be implied by the problem's wording. And this is where you have to be careful. If you only see one number in the problem or 2 numbers in the problem, you have to read the words of the problem to figure out what the other things are in the problem. And you might see phrases like, it starts at rest, the car is at rest in the beginning. Well, that means the initial velocity is 0. It's not moving, it's at rest. Or you might see that the car brakes to a stop. Well, if it's braking to a stop, that means the final velocity is 0. Or you might see a vertical problem where somebody is dropping a ball. And well, when you drop a ball, the instant your hand opens to release that ball, the very moment that you open your hand, the ball hasn't had a chance to start moving, so its initial velocity is 0. And if it's a vertical problem, you know the acceleration is g, minus 9.8 meters per second squared. So look for these clues. If you have an object going up in the air and then coming back down, you might want to split it into 2 parts. Only consider the object going up and then just make believe it stops once it hits the maximum height. Well, when it hits the maximum height, that final velocity, it's not really the final, but that final for that first half is also a vertical velocity of 0. So by reading the wording, you can get other values that might not be explicitly stated in the problem. The next step, once you decide what the givens are in that problem, you're going to be making yourself a diagram to illustrate what's happening. If it's a moving car or a moving truck, you just make a simple car for the beginning and a simple car for the end and an arrow in between, and you label them. Do I know the initial velocity? Do I know the final velocity? In between that arrow, maybe there's an acceleration or you know how much time it takes to go from the beginning to the end, from the initial to the final, or you know how much distance it takes or displacement it takes. So you can fill in, you should have 3 numbers in your diagram, and you should have a before and after picture. So then you ask yourself, what is the question asking for? Well, if it's a standard kinematics problem with 5 possible variables and you have 3 of them, they're going to ask you for the 4th or 5th variable. So you look, now you have 3 variables and you're asked for a 4th, you now look for the equation, and this goes back to the equations I showed you before. You look for the equation that has those 4 variables, but it's much easier to look for the equation that's missing the 5th variable, the one you don't care about right now. Maybe you'll care about it in the next part of the problem, but for now, you look for the equation that has only the 4 you want and not the one you're unconcerned with. And there's only one equation that will fit that. So you use that equation. What do you do once you know that equation? You write the equation down. Write it down. Don't put any numbers in it first. And when you use the numbers, look at your table of givens. That's what the table of givens is for. To take the numbers from the table, make sure you're matching the correct variable to the correct number, both in the table and in your equation. And then write the equation again a second time, but now with all your numbers in it. Make sure you include your units. Make sure you include your plus or minus signs. Make sure it has everything in that equation. Now, you should have an equation with just letters in it, then an equation with numbers in it, and one variable that you don't know the value of. That's the thing you're asked for. And now you have to do some algebra. You rearrange the equation to solve for your unknown parameter. If you have trouble doing this, you're not sure how to do this, go to one of the physics tutors or even one of the many, many math tutors that are available. Math tutors can certainly help you with solving these kinds of equations. Make sure you show your work at each step. The more work you show, the more potential there is to get partial credit on that question. You want to get all the partial credit you can if you don't get the right final answer. Once you get an answer, recalculate it on your calculator. Make sure you type the right numbers with your fingers. It's very easy to make a mistake on a calculator. Nobody's fingers are as small as the buttons on these calculators. So go through it, type it again. If you don't get the same number, do it a 3rd time. Make sure you're convinced that you've typed it in properly. And then once you have your answer, write your answer. Make sure it has units. It's extremely important to have units. The distance or displacement is going to be in meters. The velocities and speeds will be meters per second. The acceleration will be meters per second squared. And if it's a vector, you need to have a plus or minus sign in there. Which vectors? Well, in kinematics problems, all 4 of the 5 are vectors. The only one that's not a vector is time. All right? And always check your work. That means either doing the problem again from scratch as if you've never seen it before, or if you have a second equation you can use, you can plug in the numbers. But if all you've done is figured out your 4th parameter, your 4th property, there isn't a second equation you can use. Now, in many of these classic kinematic problems, you'll then be asked to figure out what's the 5th parameter, the 5th one of those variables in your original given table, the one you didn't care about up until now. The beauty of the 5th parameter is you can use any equation except the one you just used. So if you used equation number 2 to calculate your first problem, you can use equation number 1, 3, 4, or 5. In other words, anything but number 2. You just can't use the same equation twice. And then you use it, you pick the equation that's the easiest one for you to use. That might be different for different people. And then calculate it. If you have time, use a different equation and see if you get the same answer. If you've done it right, 2 different equations for that 5th parameter should give you exactly the same value. But remember, this is only if you're dealing with standard kinematic problems. If the problem, as I mentioned in the beginning, is a problem where the rate is constant, the velocity is constant, the speed is constant in one direction, it means the acceleration is 0, and don't use these equations. Just use the simplified versions of the equations written in this top line of velocity equals delta x over delta t, that's displacement over change in time, or delta x, the displacement, equals velocity times change in time. And you can think of these as speed equals distance over time, and distance equals speed times time, respectively.